2,500 years ago, a Persian engineer faced a problem that should have been impossible. His king wanted air conditioning in a desert that hit 50 degrees Celsius. No electricity, no refrigerants, no mechanical fans. Nothing modern engineers would recognize as cooling technology. So he did something stranger. He built a tower that pulled cold air out of the sky. And here's what's terrifying. That tower is still working today, 2,500 years later, in the exact same desert, cooling the exact same kind of homes, without a single watt of electricity. This is not a one-off. In ancient Iran, engineers built 6 megastructures that modern construction companies, with all their billion-dollar budgets and computer modeling, still can't replicate. Tombs carved 100 meters up sheer cliff faces, with no scaffolding. Underground water systems 40,000 kilometers long, bigger than the Great Wall of China. Built without GPS, without machinery, with a slope precision of 0.1%. A pyramid older than the famous ones in Egypt, made entirely of mud bricks that have somehow survived 3,200 years in monsoon climate. And a city 5,400 years old, that contains the oldest brain surgery scar ever discovered, the oldest artificial eye, and the oldest animated cartoon in human history. 5 of these are still standing. 3 are still functional. None of them should exist. For the next 18 minutes, we're going to count down the 6 greatest forgotten engineering feats of ancient Persia. From the oldest ziggurat to the desert city that rewrote what we thought humans could do 5,000 years ago. And by the end, you'll understand something terrifying. Modern engineers didn't just lose this knowledge, we lost it twice. To understand what made Persian engineering so absurdly advanced, you have to understand what the Persians were dealing with. In 550 BC, Cyrus the Great built the largest empire the world had ever seen. From the Indus River to the Mediterranean Sea, from the Black Sea to the Persian Gulf. 23 different cultures, 23 different climates, all under one administration, and every single one of those climates was trying to kill them. The central Iranian plateau is a high-altitude desert. Summer temperatures hit 50 degrees Celsius. Winter drops to -20. Annual rainfall, barely 100 millimeters. For comparison, London gets 600. So, the engineers faced an impossible equation. Build a civilization that needs water, in a place that has almost none. Cool homes for kings, in temperatures that boil eggs. Move armies across mountains higher than the Alps. Without modern roads. Bury emperors so safely that no grave robber could ever reach them. They couldn't import solutions. There were no solutions. So they invented them. And what they invented in 200 years wasn't surpassed by Western engineering for 2,000 more. Let me show you what they built. Counting down from number 6. Number 6. Choghazanbil. You've probably never heard the name. That's not your fault. The country that built it disappeared before Rome was even founded. In 1250 BC, an Elamite king named Naqsh-e decided to build a temple to honor his gods. Not just any temple, a 5-tier mud brick pyramid, 53 meters tall, surrounded by 3 concentric ring walls. That's 12 stories, made of dried mud, constructed by a civilization most modern history textbooks don't even bother mentioning. Here's why archaeologists call this thing impossible. Choghazanbil was built using approximately 15 million sun-dried mud bricks, each brick weighing about 14 kilograms. Each one stamped, by hand, with the king's official mark. 15 million bricks. 210 million kilograms of clay, lifted by humans to a height of 53 meters, with no cranes, no pulleys we know of, no elephants, no horses, just human muscle, and a lot of patience. But that's the easy part. Here's the part nobody can explain. The bricks were laid with no mortar. Modern construction falls apart without mortar. Brick walls require cement, lime, or concrete to hold the stack together. Choghazanbil uses gravity, friction, pressure, geometry so precise that 15 million bricks have held themselves up for 3,200 years. The structure survived when Elamite civilization collapsed. It survived when Persian armies swept through 2,500 years ago. It survived earthquakes, floods, the fall of the Roman Empire, the rise of Islam. It survived an aerial bombing during the Iran-Iraq War in the 1980s, and it still stands today. When UNESCO declared Choghazanbil a World Heritage Site in 1979, it was Iran's first one. Western archaeologists had to admit something uncomfortable. The Egyptian pyramids get all the fame, but Egyptian pyramids were stone. Stone wants to stand. Mud brick wants to dissolve, wants to crumble, wants to return to the earth from which it came. A mud brick pyramid that's lasted 3,200 years in monsoon-prone southwest Iran requires engineering that modern adobe builders openly admit they can't reproduce. We don't even know what additives the Elamites used to make their clay this durable. We just know whatever they did worked. Number 5. Persepolis. If you've heard of one Persian site, it's this one, the ceremonial capital of the Achaemenid Empire, the palace city of Darius the Great. the symbol of Persian imperial power for over 200 years. You've probably seen pictures. What you haven't seen is what makes Persepolis architecturally impossible. Construction began around 515 BC. Darius wanted a palace complex that would humble every foreign ambassador who walked into it. Something so massive, so opulent, so engineered, that no other civilization could even pretend to match it. His architects delivered. The Apadana Audience Hall stretched 70 meters by 60 meters. Its roof was supported by 72 stone columns, each one a single carved piece, 20 meters tall, 20 meters. That's a 7-story building, rendered in one continuous shaft of stone, moved from a quarry kilometers away, and stood perfectly upright, over 2,500 years ago. Modern engineers can't do this anymore. Modern stone columns are built in segments. We cast them in pieces, stack them, hide the seams. The Greeks did the same thing, the Romans too, even Renaissance Italy. But the Persians insisted on single-piece columns. They wanted no seams, no joints, no compromises, just one stone, 20 meters of perfection. How they quarried these columns, how they moved them, how they stood them up, is still openly debated. And then there are the bas-reliefs. The walls of Persepolis are covered in stone carvings, thousands of them, each one depicting tribute bearers from one of the 23 subject nations of the empire. Ethiopians bringing ivory, Bactrians bringing camels, Indians bringing gold. The level of detail is microscopic. You can see individual hairs on the beards. The exact texture of woven fabrics, the species of every flower in their hands, and every single figure is mathematically positioned with a precision that suggests the Persians understood geometry, centuries before the Greek mathematicians who would later get the credit. In 330 BC, Alexander the Great captured Persepolis. He looted the treasury. 3,000 camels were needed to carry the gold and silver out. Then, he set fire to the palaces. Why? Historians still argue, maybe revenge for the Persian burning of Athens, maybe drunk celebration, maybe a political statement. But here's what's strange. Alexander burned the wooden roofs and gates. The stone was supposed to crack and collapse. That's basic fire science. Heat the stone, it shatters. But 2,300 years later, the stones are still standing, still mathematically perfect, still showing us what one ancient civilization considered worthy of imperial pride. We have not built anything in 2.5 millennia that we would expect to last as long. Number 4, Naqsh-e Rustam, a few kilometers from Persepolis. There's a cliff face, sheer rock, vertical, about 100 meters tall, and carved into that cliff face, 100 meters up, are 4 cross-shaped tombs. The tombs of Darius I, Xerxes I, Artaxerxes I, and Darius II, 4 of the most powerful emperors in human history, carved their own graves at the top of a vertical cliff. This is where modern engineering officially gives up trying to explain things. Let me describe what we're looking at. Each tomb is carved directly into the bedrock. Not bricks, not blocks, not assembled. Carved. The entire structure, 50 meters wide, 20 meters tall, is a giant subtraction. They removed cliff face and revealed the tomb that was hiding inside. Each tomb features 2 levels. The lower level is a facade, 4 columns supporting a representation of a royal court scene. King facing fire altar, Pharaoh Bahar symbol watching from above. Tribute bearers in 2 rows. The upper level is the burial chamber, solid rock walls, a stone sarcophagus carved from the mountain itself. Now, here's the question that's bothered archaeologists for 2 centuries. How? How did they carve a vertical cliff face, 100 meters above the desert floor, 2,500 years ago, with no scaffolding? There are no holes in the rock for wooden scaffolding beams, no marks indicating ropes were anchored, no evidence of pulleys, cranes, lifts, or any structure that could have held workers at that height for the years required to do this work. Modern archaeological reconstructions guess that the workers worked downward from the top of the cliff, lowered on ropes, hammering and chiseling for years, decade after decade, inch by inch, generation by generation. But here's the problem. The carvings inside the tombs include details that are not visible from any distance. Details only carved for the king's eyes. Microscopic perfection. You don't achieve microscopic perfection. Dangling from a rope, 100 meters in the air, wielding a bronze chisel. Modern climbing experts have tested this, with ropes, with safety harnesses, with everything the Persians didn't have. They can barely position themselves accurately enough to draw a line on the rock, let alone carve dimensional sculpture. And there's something else. The tombs themselves are still sealed. In 2,500 years, no one has ever robbed them. Not because they're protected, not because they're guarded, but because they're effectively unreachable. Whatever the Persians knew about getting up there was lost when the empire fell. The bodies of Darius, Xerxes, Artaxerxes are still inside their original sarcophagi, where they've been since the day they were laid to rest. If you want to visit Naqsh-e Rustam today, you can walk to the base of the cliff, look up, and realize that for 25 centuries, no human has been able to get any closer. Number 3. Badgir, the wind catchers of Yazd. Now we're back to that first story I told you. The Persian engineer who built air conditioning without electricity in a 50-degree desert. What he actually built was the most elegant climate control system in human history. A badgir, Persian for wind catcher, is a tower that rises about 10 to 15 meters above a building's roof. From the outside, it looks like a chimney with multiple vertical slots. It doesn't burn anything. It doesn't have moving parts. It uses no energy whatsoever. But step inside a Yazd home in the middle of a 45-degree summer, and the air feels like spring. 20 degrees cooler than outside, sometimes more. Here's how it works. The tower is hollow inside, multiple vertical shafts running its full height. The top is open to the sky, with each shaft facing a different direction. Most badgirs have 4 shafts, one for each cardinal direction. When the wind blows, and in Yazd, it always blows, air is forced down, whichever shaft is facing the wind. As it descends through the tower, it cools dramatically. By the time it reaches the room below, the temperature has dropped 15 to 20 degrees. And there's a second mechanism. Most badgirs sit above an underground water cistern called a yakhchal, Persian for ice pit. The descending air passes over the cold water surface, picking up evaporative cooling. By the time it enters the room, it's not just cool. It's humidified, refreshing, and gentle. And there's a third mechanism. While cool air descends one shaft, hot air from the room rises up the opposite shaft. The temperature differential creates a continuous convection loop. Cool in, hot out, permanently, as long as the wind blows. The system works at scale. Single homes, mosques, bazaars, entire neighborhoods. Yazd, even today, is one of the hottest cities on Earth, and one of the most livable because of badgirs. Now here's what's astonishing. The first wind catchers predate the Achaemenid Empire. They were used in ancient Egypt as well, but the Persians perfected the design around 2,500 years ago, and they refined it for 2,500 years after that. Modern architects only rediscovered passive cooling in the 20th century. We marketed it as a green building innovation, cutting-edge sustainability, the future of architecture. Iranian engineers were doing it before Plato was born. In the 21st century, when air conditioning consumes 10% of global electricity production, and climate change is making 50-degree summers more common, architects are finally returning to the badgir design. Universities study it, engineers reverse engineer it, companies sell modernized versions, but the originals, the actual ancient ones, still standing in Yazd today, still work better than most of the modern copies. Because the Persians knew something we forgot. The wind blows for free. The earth cools for free. Water evaporates for free. You don't need electricity to be cool. You need to listen to your environment. Number 2, the qanats. If wind catchers are the most elegant Persian invention, qanats are the most mind-bending. A qanat is an underground water tunnel. That part is simple. What's not simple is everything else. The tunnel can be 10 kilometers long, 20, 100. The longest known qanat, the Gonabad Qanat in eastern Iran, runs for 70 kilometers underground. It was built 3,000 years ago, and it still flows today. Let me explain why this is impossible. To build a qanat, you start in the mountains. You dig a vertical well down to the underground aquifer, the natural water table beneath the Earth's surface. Then, you dig sideways, underground, following the aquifer. The tunnel descends at a precise angle of 0.1%. That means for every 100 meters of horizontal distance, the tunnel drops only 10 centimeters. Steeper than that, the water rushes too fast and erodes the tunnel. Shallower, the water doesn't flow at all. Either way, the qanat fails within months. Modern engineers with laser surveying and GPS struggle to maintain this kind of gradient over kilometers of distance. The Persians did it with sticks, plumb lines, lamps, and math. Their math was good enough that the longest qanat, 70 kilometers long deep underground, maintains its precise gradient from start to finish. Built 3,000 years ago, still flowing today. And there's more. Every 50 meters along the tunnel, a vertical access shaft was dug from the surface down to the tunnel. These shafts let workers remove dirt during construction, let them ventilate while digging, and let them maintain the tunnel afterward. In a typical Iranian landscape, you can spot a qanat from the air because the access shafts form a perfectly straight line of holes, kilometers long, marching across the desert. There are over 30,000 of these systems in Iran. Some are short, a few hundred meters. Some span entire watersheds. Together, their tunnels total over 40,000 kilometers, longer than the equator, built underground by hand, mostly between 3,000 and 2,000 years ago. And here's the part that should genuinely change how we think about ancient civilization. The qanat system worked so well that it spread. The Romans copied it for parts of North Africa. The Arabs adopted it in Spain. The irrigation systems of Andalusia descend directly from Persian qanats. The Spanish brought it to the Americas. The qanats of the Atacama Desert in Chile were built by Persian-trained engineers traveling through colonial networks. Even today, when you fly over rural Iran, you can still see qanat lines stretching to the horizon. Some abandoned. Many, 5,000 of them, still operational. Still delivering water to farms and villages that have been continuously inhabited since the qanat was built. Modern dams cost billions and last 50 years. Persian qanats cost dirt and lasted 3,000. Number 1. Shahr-e Sukhteh, the burnt city. This is the megastructure that breaks the rules. In southeast Iran, near the border with Pakistan and Afghanistan, there's a stretch of desert that looks completely lifeless. Nothing grows, nothing lives there. Even Bedouin tribes avoid it. But underneath that desert is the largest known Bronze Age city in the world. Shahr-e Sukhteh was founded around 3200 BC. It thrived for over 1,000 years. At its peak, it had a population of around 20,000 people, making it one of the largest cities anywhere on Earth at the time. And then, around 1800 BC, it burned. Hence the name, the Burnt City. The fire was so devastating that the inhabitants never returned. The desert reclaimed it. The civilization that built it disappeared from history. We only rediscovered it in 1967. Here's what we found. A surgical skull, 5,000 years old, belonging to a young girl, with a perfectly drilled circular hole, 3 centimeters in diameter, cut into the temporal bone. The edges of the bone show clear evidence of healing, which means someone performed brain surgery on this girl 5,000 years ago. And she survived. For months, maybe years. This is the oldest known successful surgical procedure in human history, performed in a city that history doesn't even remember. Then we found the prosthetic eye. The skeleton of a young woman, 4 feet 10 inches tall. In her left eye socket, an artificial eye, 2.5 centimeters in diameter, made of tar mixed with animal fat, decorated with gold wire forming the pupil and engraved iris lines, held in place with golden thread that passed through tiny holes drilled through the eye. The oldest artificial eye in human history. Functional, aesthetic, indistinguishable from human craftsmanship today. Then we found the dice. 20-sided dice, 5,000 years old. The oldest backgammon board ever discovered, complete with playing pieces. And then we found the goblet, a simple clay drinking cup, about 13 centimeters tall. Around the outside, an artist had painted a goat in 5 different positions, standing, lifting its head, bringing its head down, reaching to eat from a tree branch, and reaching slightly further. When you spin the goblet, the goat appears to move, to eat from the tree, to breathe. It's the earliest known example of sequential animation in human history, 5,000 years before Walt Disney. This is what Shahr-e Sukhteh tells us. In a city we didn't know existed, in a civilization we can't name, at a time before recorded history began. People were performing brain surgery, making prosthetics, playing complex games, and inventing animation. Then they vanished. We don't know who they were. We don't know what language they spoke. We don't know what they called themselves. All we know is that 5,400 years ago, in a desert that nobody else thought was livable, they built one of the most sophisticated cities the ancient world ever produced. And then a fire took it. And the world forgot. 6 megastructures, from 6 different eras, each one impossible. Together they tell a story that doesn't fit our modern narrative of progress. We like to imagine history as a straight line, caves to villages to cities to skyscrapers, each generation building on the last, always advancing. But ancient Iran proves that's a lie. 5,400 years ago, surgeons performed successful brain surgery. 3,000 years ago, engineers built underground water tunnels longer than the equator. 2,500 years ago, architects built natural air conditioning that still works today. 1,200 years before Christ, builders raised mud brick pyramids that have outlasted every imperial dynasty since. And then, most of that knowledge was lost. Not because the Persians stopped knowing it, they knew it for centuries after. But when their empire fell to Alexander, then to the Sasanians, then to the Arab Caliphate, then to the Mongols, then to modern colonial powers, each transition lost something. Each time a library burned, each time a scholar fled, each time a tradition was suppressed, another piece of the engineering legacy disappeared. We didn't surpass ancient Iran. We just outlived its memory. If you found this video valuable, and you want me to keep finding stories like this, subscribe and ring the bell. I'm building a library of every ancient engineering achievement modern engineering can't replicate. Next video, we leave the past and travel forward into the future, to the most expensive mega project in human history. A $1 trillion city being built right now, in the desert just across from Persia. It's called Neom, and it might be the most spectacular engineering failure of our generation. You won't want to miss it.